Hey, what is up, GCSE Maths kids? Let's go through the answers to my circle theorem questions from this week. Ready? Work out the values of angle A and B here. So first thing I see is that angle B is going to be 360 degrees minus 94, which is going to be 266. Why? Because the angles around a point sum to 360. Angles around a point sum to 360. Fine. And the second thing I see is that angle A is going to be half of angle B, which is going to be 266 divided by 2, which is 133 degrees. And this is because for angles subtended by the same arc, so I'm drawing the arc here in blue. Oh, let's try that again. Yep. So for angles subtended by the same arc, the angle at the center, so B here, is twice the angle at the circumference, which is A. So in other words, A is going to be half of B, which is going to be 133 degrees. And the circle theorem we're using is angles A and B are subtended by the same arc. In your exams, you may have to write the full explanation, which would be for angles subtended by the same arc, the angle at the center is twice the angle at the circumference, but I don't have time to write everything out in full here. So let's move on. Question 2, what is the value of angle X? So again, the first thing I see is that angle CAD is equal angle CBD. CAD in blue here is the same as CBD in blue here. So angle CAD is going to be 60 degrees. And they're the same because the angles in the same segment are equal. Let's see. Angles in the same segment are equal, which is the same as saying for angles subtended by the same arc, in this case CD, the angles at the circumference are equal. This is the same as this rule here. Angles in the same segment are equal. Cool. So now that we know that CAD is 60 degrees, we're going to fill that in. So X is therefore going to be 180 minus 60 minus 25. So X is going to be 95 degrees because the angles in a triangle, of course, sum to 180. Question 3. What are the values of A and B? So the first thing I see is that A is going to be 50 degrees. And this is because the angle between the chord and a tangent to a circle, so this one here, is equal to the angle in the alternate segment, so this one here. So A is going to equal 50 degrees. And this is the alternate segment theorem. Perfect. And now that we know that A is 50 degrees, angle B is going to be 180 minus 50 minus 70, which is going to be 60 degrees. Because the angles in a triangle sum to 180 degrees. Perfect. Let's move on. The next question. What is the value of angle ACD, the red angle? So the first thing I see is that angle BAO is 90 degrees. And this is because the angle between the tangent to a circle and the radius of a circle is 90 degrees. So the rule here is that the angle, no, hold on. Let's do it this way. The radius of a circle meets the tangent at 90 degrees. Cool. So tangent BA meets radius AO at 90 degrees. And therefore, the second thing I see, because angles in a triangle sum to 180, that angle AOD here in black is going to be 180 minus 90 minus 20, which is going to be 90 minus 20, which is going to be 70 degrees. I'm not going to write down the rule here because I don't have space. And so the third thing I see is that angle ACD, which is what the question's asking us to figure out, is going to be 70 divided by 2, which is going to be 35 degrees. Why? Because of a rule that we touched on earlier, which is that for angles subtended by the same arc, let me change my color here. So in this case, arc AD is subtending angle AOD and ACD. So for angles subtended by the same arc, the angle at the center is twice the angle at the circumference. So ACD is going to be half of AOD, which is 70. So ACD is going to be 35 degrees. AOD and ACD are subtended by the same arc AD. Perfect. Next question. What is the value of angle ABC? So the first thing I see is that AB is going to be equal to BC. So these two tangents are equal in length, because when two tangents to a circle meet at an external point, they are equal in length. So that's the circle theorem, but we don't actually need that to work out the answer. We need another rule from earlier, which is that the angle between the tangent to a circle and the radius to a circle is 90 degrees. So these two angles here, angle BAO and angle BCO, are equal, and they're both equal to 90 degrees. And using the circle theorem, that between the radius and tangent is 90 degrees. Okay. And the third thing I see is that angle ABC is going to be 360 minus 90 minus 90 minus 95. So angle ABC is going to be 180 minus 95, which is going to be 85 degrees. And I will put the explanation here. And this is because the interior angles of a quadrilateral sum to 360. Okay, perfect. Next question. What is the value of angle X? So here we are going to use the rule that the angle in a semicircle, which I'm outlining here in green, the angle in a semicircle is always 90 degrees. So angle ABC is going to be 90 degrees. Perfect. So the second thing I see is the angles in a triangle sum to 180. So 90 plus x plus 2x is going to be 180. So 3x is going to be 180 minus 90, which is going to be 90. So x is therefore going to be 30 degrees. Perfect. Okay, last question. What are the values of a, b, and x? All right, so the first thing I see here is that angle BCD, which is this one, plus angle BAD, which is this one, equal 180 degrees. Why? Because of the circle theorem that opposite angles in a cyclic quadrilateral sum to 180. Opposite angles in a cyclic quadrilateral sum to 180. So, therefore, angle BCD, which is A plus B, plus angle BAD, which is 30 plus x, is going to be equal to 180. Now, we've been told that angle A plus B equals 100 down here. So we can exchange this for 100. So A plus B, which is 100, plus 30, plus x equals 180. So 130 plus x equals 180. Let's move this down. So x therefore equals 50 degrees. Perfect. So now how are we going to work out what A and B are individually? We know they sum to 180, but what are their actual individual values? Well, to do this, we need to know that the angles in a triangle sum to 180. Let's break them up into their individual triangles. So we have triangle ABC here, and we have triangle ADC here. So in triangle ABC, all three angles will add to 180, right? So 30 degrees plus A, 30 degrees plus A plus angle ABC equals 180. Now, what is angle ABC? ABC is going to be 90 degrees. Why? Because of another circle theorem rule, which states that the angle in a semicircle, like so, because this is the center, the angle in a semicircle is 90 degrees. So ABC is going to be 90 degrees. So we can change this to 30 plus A plus 90 equals 180. So A is going to be 180 minus 90 minus 30. So A is going to equal 60 degrees. Perfect, and I'm out of space. Let's make all of this smaller to make space for the second part of the question. Now if we look at triangle ADC, we know that x in ADC is 50 degrees from up here. So x is going to be 50 degrees plus b plus angle ADC is going to be 180. Now, angle ADC again is like ABC. It's the angle in a semicircle. So ADC is also going to be 90 degrees. So we have 50 plus b plus 90 equals 180. So b equals 180 minus 90 minus 50, and b is going to equal 40 degrees. Okay, perfect. Those are all the questions, so that is all for this video. If you found this video helpful, please do hit that like button and subscribe for more content at tutor_Jane. And if you think anyone else you know might find this stuff useful, please do share it on. One last thing, if there are any GCSE Maths topics that you guys are struggling with, please do let me know and I will try my best to cover them. Okay, that is all for this video. Thank you for watching and I will see you guys next time. Bye for now.